All right, everyone. I think we're going to get started. Thank you again for coming. This is our second lecture with the Python workshops. So just a quick review of the first lecture. We went over number types, we went over strings, lists, dictionaries, tuples. Today we're going to pick up on files. So this is going to cover kind of how you read in and write out to files in Python. It's relatively simple. So if you guys want to go into your REPL.it, and right over here you can add a new file. And just go ahead and add a text file, and you can just write whatever you want in there, just one little line of text. And we're going to be basically reading and writing from that file. So basically what we do when we want to open a file in Python, we use the built-in open function. So if I want to read in this file, what I would do is I would create an object, my file. And what I would do is I would assign to that whatever this function gives me. So the open function, and I pass the name of the file as a string. So I decided to name it test.txt. You could name it whatever you'd like. So what this does is this opens this file within this object that we created. Now you can read in that file using the .read function. And so how we would denote that is we would call our object, my file, and we would give it the dot and put in the read function. So what this does is the text file has a cursor, basically. Think of it as a cursor. It's not actually a cursor. At the very first element of the file. And what read does, it will basically read through the file. And I'm going to actually print this out so you guys can see it. So I'm going to print as you can see here. This is what we had written in our file. So something to note, like I said, there's kind of like a cursor that goes through the file and kind of keep track of everything that's going on in there. So if I were to try to do this twice, what you would notice is that it only prints it one time. And the reason why it's doing that is because once it reads through it, at the end of this line right here, our imaginary cursor is at the very end of the file that we're reading. So when we try to read it again, it just gives us a blank because it's at the end of the file. So, it just gives us what's there, which is nothing. So if we want to make sure that we go back to the beginning of a file, what we use is we use this function seek, which kind of takes you to any particular location within the file. So if we call myfile.seek and pass the argument as 0, what that does is it takes us, brings the cursor back to the beginning of the file. So if I were to do that and then read the file again, see it prints it twice. So it prints it one time, sets the cursor back to the beginning of the file, and prints it a second time. So there's another function that you could use called read lines, and what this does is it returns a list of, and for each element in that list is basically a line in that file. So if I were to go back to this file and add, this is a second line. Now I would call my file .read lines. I'm actually going to print this out so you guys can see it. Right, so as you can see, the square brackets represent that we have a list, and within the list we have two strings, one representing each line. I wouldn't recommend using read lines if you're dealing with large files, because, for example, you're going to end up with a giant list which takes up a lot of memory because you are creating a new list with all this data. Whereas with the read, you're simply reading into the file that's already created. So you're not using up any extra memory space. So read lines would be like something if, for example, I have a large file and I just kind of want to get a quick preview of like the first line, for example, then I would just do, I would call the read lines function and just pass it an argument of 1. And that'll just give me the first line. So it's like a quick preview. So if we want to write into a file, so I'm going to go back to my text file. I'm going to get rid of all this text. So we're starting with a blank text file. The open function takes in multiple arguments. So the first argument that we give it is the name of the file that we're opening. And the second argument is passed through a string as either W, which stands for write, R, which stands for read, or you can do W plus or R plus. So W plus means I'm opening this file with the intention of reading and writing to it. So once I pass that argument, now I can write into the file. And we do that by using the write function. So I would do my file dot write, and I would pass whatever string I'm trying to write. So I just added this new line. Right. Now we run this, because I'm not printing anything, you're not going to see anything down here. But if we go back to our test file, you can see that this line of text has been added to it. And if I run this program again and we go back to it, we can see that it, right, so it's not doing it. So now if we go back to read this file, so let's write into it and then read. I'm going to print this out. Right, see, so our cursor after this input was at the end of the file. So for that reason specifically, it's giving me a blank. So I'm going to have to make sure to set that cursor back to the beginning of the file. And there we go. We just added a new line. Now I'm going to show you how to iterate through a file. So what iterating is basically, question?
How do you know which functions require you to set the cursor back at the beginning? Like we have to set the cursor back at the beginning for read lines and write and read. Are there any that you don't have to set it back at the beginning?
Generally speaking, for most of the time you're dealing with these type of files. Also keep in mind too, if, for example, every time I run this file again, what it does is once I execute this file, it closes that text file, and it's like a done deal. But so if I just write, for example, let's say I just open it, we have our text in there, and what I do is read it. So what this is going to do is this is going to, yeah, so in most cases, it's safe to just make sure your cursor is in the beginning. I'm not sure if there are specific functions that disregard that. Probably, I would assume, I know there are similar functions in C++ like peek, for example, and what they do is they just kind of take a quick little look ahead of what there is specifically, but it doesn't actually move the cursor to that point. I'm not sure if there's anything specifically like that in this case. There probably is. I would check the documentation, but for these functions that we're using right now, it's you're going to be wanting to make sure that you know where the cursor position is within the file. So for iteration, what we can do is we can use a loop, and we're going to actually get into the loops right after this. So this is kind of like a quick little preview. We're going to use a for loop. Let me just make sure. We're just going to read the file. And I'm going to say for line in my file. print the line. So a couple of things that I want to let you guys know about Python specifically. It's not like specific other languages where you use brackets a lot of the times to specify what's going on inside or outside of these statements. Also, notice how I wrote line here, and this is basically, it's arbitrary what specifically you put in here. So for example, I could have said for X, for something. This is basically just, yes?
So my file is a list?
Your file is a list?
Is my file a variable is a list?
No.
Oh, it's an iterable.
It's, yeah, so it's just basically you're reading, I guess you could kind of think of it as a string, because depending on what's in here, you know, like for example, I have text in here, but if I just had like number data, like if I just had like 245, 560, it would kind of just read this as if it were a string. In the case where you want to list, the read lines function actually takes each line and puts it into a list, but it's not in a list otherwise. So for this for loop, basically what the for loop says is for any element, right, within this object. And the great thing about this is it doesn't really matter what exactly the element type is. So for example, if I had a list, right, and we're going to get into this in the next one as well. Basically what these are just saying is give me a specific element within, you know, anything that we have. So in this case, I would say for element in L, which is a list. So in this case, these specific elements would be numbers. Then I would say print whatever word I use to describe those elements. So in this case, it's element. I can, you know, use anything. I can use ASDF. Basically, the convention with this is use what you think would help you understand what's going on the best. So in this specific case, I'm reading lines in a file. So I would specify that the specific element that I'm iterating through are lines. And I would say print, not booleans, lines. And the file is blank, so we're going to add some new lines here. First line, second line, third line. There you go. So what this does is, once you get into the for loop, it says, okay, so for every one of these elements, which in this case, the element for the file is each particular line, I want you to print each one of those lines. And once we reach the end of this file, it simply terminates the loop and jumps outside of it, and then it terminates the program. So there's multiple ways to do this, but generally this is the cleanest approach. And over here, if you can see, it's talking about specifically how the word itself that you use to describe the element in whatever you're using is rather arbitrary. It's mostly just so you use words that are appropriate for the specific situation. So that's basically simple in and out of files. The next thing we're going to cover are sets and booleans. So booleans are definitely going to be the more important subject in this specific lesson. So what sets are is they're a bit like a list, but they are unique elements. So for example, if I were to create a set, right, and this would be an empty set. I haven't put anything in there yet. And then I want to add, so there's an add function for sets. So I would just say add 1. And what this would do is it would add the integer 1 into my set. So now when I print my set, we can see, so it gives us curly brackets, which is similar notation to what we would see in dictionaries. But the thing about sets that's different is think of them as a dictionary with only keys. So they're not necessarily referencing to any value within. They're just a set of unique elements within this sort of list. So to show what I mean by they're unique, so what I'm going to do is I'm going to add a 2, and then I'm going to print it, and then I'm going to add another 1. Print it again. And what we're going to see is that even though I'm telling it to add another 1, because it only accepts unique elements, it's actually going to say, hey, I already have a 1, so I'm not going to actually do anything with that 1. So we can also do things like, for example, if I had a list with repeated elements, which in the case of a list, that's totally fine. The list doesn't care if you have repeated elements. And we wanted to cast this list. So basically take the elements in this list and turn them into a set. What I would do is I would say S equals set of this list. What this does is it takes this list and turns it into a set with only unique elements. So when I print list and print my set, we can see the difference. So this is our list with all of our repeated elements, and this is that same list cast into a set where all we're left with are specific unique elements. All right, so now we get into the Booleans, one of my favorite parts. Basically what Booleans are, Boolean statements are as simple as true and false. And they're represented as 1s and 0s, but when we type true and false, that's basically determining the specific choice that we make. So it's really like a coin toss or a simple 1 or 2 choice. So in other programming languages like C++, you would have to specify that an object is of type Boolean. So we would have to specifically write, bool a equals true. But Python has the fantastic ability to automatically recognize what specific type of element you're putting into an object. So just by typing a equals true, it knows that a is a Boolean value represented by 1 or 0. So true in this case would be 1, false would be 0. So if I wanted to print a, we would see it's just true. So ways we get Boolean outputs out of comparisons are, so we've all taken math in high school, so we understand some simple comparison operators, things like less than, greater than. In Python specifically, because the equal sign is reserved for assignment, what we use to represent the Boolean equals is 2 equal signs. So if I said 1 is equal to 2, that's obviously false, right? So if I were to print this, Boolean evaluation, what I would end up with is a false statement. For example, if I said 1 is less than 2, that would evaluate and return to me as a true state. There's also less than or equal to, greater than or equal to, and then just like we have the double equal sign for true, we have the exclamation point equals for not true. So not equals to, I'm sorry. So this says 1 is not equals to 2, which is true. So if I run this, it will return true. There's also a simple placeholder. So let's say I create a Boolean object b, but I'm going to work with this and I'm going to assign different values to this as my program goes along. So for the time being, I've just created it and I just want to kind of set a placeholder. So it's not true or false. It's just kind of waiting to be given a value later on. I would just pass it none. So it's pretty straightforward. Boolean operators are very simple, but they're extremely useful for programming, and we're going to get into why. So we're going to start part 2 now, and this gets a little more into the comparison operators. So we have a table of comparison operators over here. We have the equals, we have not equals. This is also another way you could write not equals, but generally convention is to write it with the exclamation point and equals. Greater than, less than, greater than equal to, less than equal to. And you can see some brief examples here. Right, so 2 is equal to 2 will obviously return true. 1 is equal to 0 is false. 2 is not equal to 1 is true, and so on and so forth. Right, these are all just a bunch of examples to kind of highlight all of those things. Now, we can also chain comparison operators. So we can do things like, 1 is less than 2, which is less than 3, which is going to evaluate to true. And we could also use specific Python statements like and or. And or work just like they do in any type of normal logic. When we have an and statement that's evaluating 2 separate Booleans, we say if both of these conditions are true, then return true. If only one of these conditions is true, then you're going to return false, because and specifies that we want both of these cases to be true. Right, and I'll show an example of this right here. So if I say, let's see, if if 5 is less than 3, let's do it the other way around. If 5 is greater than 3 and 5 is greater than 1, then you're going to print a smiley face. And it's, there we go, smiley face, yeah. But if, for example, I change this to a 6, so the first Boolean statement is still true, 5 is greater than 3, but the second is not, and that means if one of these is false, then we're not going to ever reach this print statement, because this condition for our if statement is not met. We're only going to print if this condition is true, and if one of those is not true, then the entire condition is not true. It's pretty straightforward. Now we're going to get into statements, Python statements. So this is kind of just a brief write-up about the differences between Python and other languages when it comes specifically to statements. So for example, in C++, in an if statement, you might see something like this. So we have our if followed by our condition, which is nested inside of round brackets. And then we have these curly braces that basically mark the beginning and end of this if statement. In Python 3, we kind of get rid of all of this clutter. And the way we do that is by being careful with our indentation. So Python is very sensitive to indentation. And how we would convert something like this to this is we would just say if A is greater than B, and then we would follow it with a colon, which indicates that this is the end of our condition. And then when we press enter, we make sure that there is one tab space, and a tab is 4 spaces. So this is very kind of specific to Python. You got to make sure with every indentation you're dealing with 4 spaces or a tab. And then we kind of place everything we want to happen within that condition on that specific indentation. So if I wanted to do some more stuff within this specific indentation, I would keep it indented there. If I kind of back it up over here, this isn't going to read as being part of this if loop. So you have to really be careful with your indentation. Like for example, if I put the print statement all the way at the end of this line, that would execute regardless of whether or not the statement evaluates or not. So in this case, you see that this evaluation came out to false, so it didn't print out the smiley face, but this print statement is outside of this if statement. So it went ahead and printed it anyway. But if I were to indent it, we can see that it's going to print nothing, because now both of, inconsistent use, see, Python is so sensitive that you have to choose whether you're using tabs or spaces specifically. So A lot of people, it's kind of like two schools of thought. You know, people say you have to use 4 spaces, and other people are like you have to use tabs. It doesn't really matter as long as you're consistent. You know, you can use 4 spaces. They basically, you know, there you go. You got nothing printed out because this is a false statement. If I made this true, then you would end up with both. So indentation is very important. So an example of this would be, you see in this block of code right here, what we have is an if statement followed by an indentation, followed by another if statement, followed by whatever we're trying to do inside of this nested if statement. And when we break out of that, we go all the way back to the beginning right here and give our else condition for the if statement. And we're going to get into that right now. So if, elif, and else statements. So what these are basically, they're a way of determining different cases and what to do in those specific cases. So over here we see a general form. We state if case 1, then we perform action 1. Elif is kind of like a shortened version of else if. You know, you can write else if and that will work fine, but this is just a bit shorter. So it says, you know, if case 1 is true, perform this action. In the case that case 1 is not true, it's going to skip over this entirely. And it's going to jump straight to our second case. Else, if case 2 is true, then perform the second action. And if none of those if conditions are met, we have kind of like a fallback and else. So otherwise, perform action 3. All right, so we have some quick examples here. So if true, when you pass a Boolean statement of true into an if statement, it's always going to execute that, because what if is checking for is if the case is true or not. And we're basically giving it a true case in all circumstances. So this is a little bit different. So we set x as a Boolean false. Then we say if x, right? And what if x is saying is it's saying if x is true. And in this case, it's not true, it's false. Print x was true. Otherwise, in the else statement, I will be printed in any case where x is not true. And in this case, x is not true. So we skip this first block entirely, and we get to this else statement, which gets printed. You have multiple branches. So, for example, this creates an object of type string and titles it bank. And then it says if the location is double equals to the auto shop. So it's this statement basically checks to see if this string location, or LOC, is the same as auto shop. And if it is, then it'll return a true statement. If it's not, then it'll return a false statement. And in this case, it will return a false statement. So this print statement will never be executed. Otherwise, if our location is the bank, then we're going to print this statement here. And this is our kind of fallback, else print where are you, because it's not really specified where the location is. And when we run this code, we see that we get welcome to the bank. And just to show you how this would work, if I were to change the location to auto shop, and this is going to give me an error because I need to specify these print statements as functions. And we can see it says welcome to the auto shop. So it's a great way to kind of like direct your flow of work in specific directions. And we're going to get into some projects with this in the future. So for example, here's another example. These are relatively simple examples, but the concepts can get very complicated. And you can have multiple if statements nested within if statements. So we got something simple. So if the person is Sammy, print welcome Sammy, otherwise print what is your name. Same with this one. And remember, indentation is extremely important. So all of these if, elif, and else statements all lie along the same indentation. and each one of these nested statements within these conditions is a tab or 4 spaces in. Right, so that covers the basics of those specific statements. Now we're going to get into for loops. We used a for loop earlier, but we're going to kind of get into the general format for what a for loop is. So in general, this is kind of the way we go about it. We say for a specific item within this object, we give it some command to do stuff, right? So an example would be if I wanted to iterate through this list. An iteration basically is when you step by step move through each element in the list. I'm going to create a list. And I make a simple for loop for number. And again, this indicator is arbitrary, so I could say for item, for x, for number. I just have to make sure that's what I reference specifically inside of the body of the for loop. So for number in L, colon, indent. For some reason, this is not saving the way I want it to. Yeah, so generally most text editors will automatically indent 4 spaces. This one's being a little weird with me, so in the options you can specify what type of indentation and indentation size. But we're just going to go with whatever they're giving me. They'll probably work. If it doesn't, I'll just manually indent them myself. So I'm going to say print that number. Before I execute this, I just want to explain what it's going to do. So it's going to say for every element in this list, what I want you to do is I want to iterate from the beginning to the end of this list and print every value independent of one another. As we can see, we have a list of 1 through 10. Same here. So there's another operator that we didn't cover. So the modulo, which is a percent symbol, what this does is it's kind of like it gives you the remainder of a division. So if I have, if I print 6 divided by 2, this is going to give me 3. But if I print 6 modulo 2, what this does is it gives me the remainder after the division of 6 and 2 is completed. In this case, it's going to be 0. All right, let me not print this just so you guys can see it. So over here we have 3, which is the division of 6 and 2, and we have 0 for the modulus. So modulus is very helpful when you want to do things like separate even and odd numbers in a list, right? So let's go back to our for loop. For num, I'm just going to keep it short, in list, or L. And then I'm going to put an if statement within this. So I'm going to say if num modulo 2, and when we do modulo 2, we're basically really putting it into 2 categories, because every number will either give us a remainder of 0, in that case they're even numbers, or it'll give us a remainder of 1, in that case they're odd numbers. So basically what I'm saying with this if statement is I'm saying if this number is even, oh, I'm sorry. Yes, number modulo 2 equals to 0. So what this statement over here is saying is, if this number's remainder when divided by 2 is 0, which describes all even numbers, then what I want you to do is print that number. And what this is going to do is this is going to print every even number within the list, 2, 4, 6, 8, 10. To demonstrate some of the statements, I can also say else. And there's no need to specify, like I know you're thinking if I want the odd numbers, then I would just do an elif statement, and I would say number modulo 2 equals 1, right? But in this case specifically, there's only 2 conditions, right? Either it's an even number or an odd number. So if it's not an even number, then I know automatically that it's going to be an odd number. So I don't need to specify that condition. I can just say otherwise print this is odd. what we can see is for all the odd numbers in our list, they didn't satisfy this condition. So this print statement never got executed, and they fell into the else category, and it just printed this as odd. So for our 1, 3, 5, 7, 9, we all have a print statement stating that. All right, so this is some stuff on Modulo. We have some examples. Right, so another thing that you can use for loops for is you can use them to sum numbers, right? So I have my list, and let's say I want to add all these numbers up, but I really don't want to say sum equals, you know, first index of L or 0th index of L plus the first index of L, and so on and so forth. That's a little arbitrary. So what we do is we initialize this object with just a value of 0. Then we say for every number in our list, I want to add that number to our sum. So I say our sum is equal to itself plus whatever that number may be. A simpler way to do this, so if I execute this and then I jump out of this for loop and I print my sum, I'm going to get 55. Perfect. If you guys want to actually add that up by hand and see if that's right, you know, feel free to. I'm not going to do that. So another way that we could do this, so every time you're incrementing and you're adding more onto a specific value, there's another operator called the plus equals minus equals operator, which, oh, yes, that looks a little weird because sum and num look very similar. So I'm just going to go ahead and change this to n, just so people don't get confused. So what I'm going to do is I'm going to remove the sum from this side. And over here, instead of equals, I'm going to say plus equals. And what this says is, I want you to take the sum value, and I want you to set it equal to itself plus whatever value is on the right-hand side of the operator. So this is the equivalent of sum. This is the equivalent of, no caps lock, come on. I don't like loud caps locks. This is the equivalent of sum is equal to sum plus n. It's kind of a little simpler way to put it, and this also applies for all the other operators. So you could do minus equals, you can do times equals, which is a star operator. You could do divide equals. You could also do modulo equals, which is pointless, kind of. Not really. Don't quote me on that. So that's pretty straightforward with the for loops. It's not too complicated, the stuff we're doing. I mean, ultimately, these simple concepts can be used with much more complicated information. You could be dealing with dozens of variables that you're using all of these statements and loops for. But this is kind of just basically so you get the gist of it. Also, we can use loops to iterate through strings as well. So if I had a string, in this case what they did is they actually put the string inside of the for loop evaluation, which is great, but I would prefer to do something like s equals, this is a string, and then when I say for letter in s, it's the equivalent of what this statement says right here. So if you want to save yourself a line of code, you could, instead of declaring s as this string, you could just, if you want to save some memory, you don't want to store this in memory, for example, you can just write it in here instead. I'm going to print that letter. There we go. We have a nice little column of letters. All right, so now we're going to get into tuples in looping. And tuples have a specific feature that's unique in terms of looping. So the first example, as you can see, it's pretty straightforward. It's just like a list. But for example, if we had a list of tuples, right? So if I had a list that was comprised of various tuples, And if you remember from last Friday, tuples are immutable. So once you've declared whatever the size or the contents of that tuple, it's fixed unless you override it with some type of new information. So let's see. We don't need to make this too fancy. That should be good. So now when I say for, I'm just going to say t, or for tup in my list, I want you to print that tuple. Now, this is pretty understandable, but what if we wanted to access specific elements within that tuple? Right? What if I wanted just the first value and not the second value? Well, then what we can do over here is we can specify, and what this is called is, it's called tuple unpacking. So what we're going to be doing is we're going to be unpacking these tuples within this for loop. And that can be done like so. We specify tup1 and tup2. So and this is what the unpacking is right here. So we're saying for the first, for tuple 1, tuple 2, and this isn't talking about, this first tuple 1 and 2 and the second tuple 3 and 4. This is talking about the elements inside of the tuple. So write t1, t2, and then if I say just print t1, what it's going to do is it's going to print the first element in each one of those tuples. Right, so you'll get 1, 3, and 5. And I could also, if I wanted to, I could print t2. There we go. 1, 2, 3, 4, 5, 6. Well, 1. Yeah. So what this is doing is basically it goes through the for loop the first time, prints the first element of that initial tuple, prints the second element of the initial tuple. Then it goes up to the for loop again, jumps to the next set, prints the first, prints the second, goes up to the top again, prints the first, prints the second. We could also do something similar with dictionaries, except we're going to need to call a specific function. So let's say I have a dictionary. K1. K2. And what the K's are, they're basically the keys. And so the left side of the colon is the keys, and the right side of the colon is the specific elements that the keys are holding. If I said for item in my dictionary, print that item. What you're going to notice is we're just going to get keys, right? So we just get key 1, key 2, key 3. If you wanted to access the specific items that those keys are holding, what we're going to have to do is, instead of calling just the dictionary, we're going to have to specify a function titled items after that dictionary call. And we're going to have to kind of unpack this dictionary into keys and items. And remember, these words are arbitrary. So I mean, I could just say K and I. And K, which is the first thing that I'm passing to it, represents the first thing over here, which is the key. And I represents the second thing over here, which is the item. So now I would say print I. What this will do is this will give me all of the elements inside of those specific keys. So, I could do something like, if I only wanted to print the first and second elements from the first and second keys, you can specify things like, if K is equal to K1, then I want you to print the item associated with that. And this will only give me 1. If it decides to load. There you go. So every time it loops through this, it checks if my key is equal to key 1. So the first time around, this evaluated to true, it printed the item associated with that key. Every other time it ran through this evaluation came out false. So it didn't end up reaching the print statement at all. And this is basically a little explanation of what I just showed. Now we're going to get into while loops. While loops is probably the most general type of loop that you're going to be using. Basically what it is it says, while this condition is true, kind of like the for loop, then you're going to execute some code. And oftentimes the else statement within a while loop is very optional. So, I could do something like set a variable x equals 0. And the thing with while loops is, I'm going to let you guys know now before you actually execute anything, is you can most definitely create a never-ending loop using while loops. And this is not fun. You don't want to just have stuff going forever on your computer. So we have to, if we say, for example, while x is less than 10, if we don't increment x within this loop, it will always be less than 10 because it's 0. So it's just going to execute whatever's in this loop forever and ever and ever until you hit Control C or Command C, which will, stop the program. So it's good to know Command C, Control C if you're ever stuck in a never-ending loop. So what I'm going to say here is, while x is less than 10, I'm going to print x. Then I'm going to say incrementing x by 1, x is now, and then I'm going to print x again. Then what I do here, before I close myself out of the loop, I make sure to increment x by 1. So I say plus equals 1. And what this does is every time we go through this loop, right, x starts at 0, then we're going to print 0, then we're going to say incrementing by 1, x is now 0. Then this statement says x is plus equals to 1. So this is equivalent to saying x is equal to x plus 1. So in C++, you might see something like x plus plus, which is a shortcut for increment by 1, but in Python that's not available, so we just go x plus equals 1. And when I run this, right, if I go down here, what you're going to see is we started at 0, x is incrementing by 1, x is now 0, then we increment, x is 1, x is now 1, increment 2, 3, 4, all the way to 9. And then right after 9, when we say we're going to increment by 1, this value, x, becomes 10 right here. And then at the top, when it tries to evaluate this again, it says, oh, x is not less than 10. This is false, so now we're out of the loop. So, oftentimes you'll write a while loop and you'll forget to increment, and you'll just end up with a never-ending while loop, and that's not fun. So just, be aware of that. Usually when you write a while loop, you want to write the incrementing at the bottom first, just so you don't forget. Yeah, so you can also pass else statements, which will evaluate after the while loop is done. Oftentimes, in most cases, you're just writing a while loop to take care of some activity a repeated number of times. It's not really necessary to specify an else statement, but it is possible. We also have these statements within a while loop, and basically you just write them out over here. So, like for example, if over here I wrote if x is equal to 5, then I just want you to break. And what that does is it will break out of this while loop entirely. So if I run this again, as soon as we hit 5, if x equals 5 break, it just jumps right out of the loop entirely. Continue is used to send you back up to the beginning of the while loop. So for example, let's say I'm printing out each one of these numbers, but for some reason I don't like 5. So I don't want it to print 5. Right? So what I'm going to do is I'm going to say if x equals 5, continue, else print x. Oh, I see. So I'm going to have to specify this before. These darn internet compilers take forever to. Wait. Just don't think I pressed enter. Oh no, Reptil stopped. Right, so in this specific case, actually, the reason why it's not working the way that I was hoping it to is because this continue statement is breaking out of this if statement, not this while loop. Right? So continue, break, and pass, they work within most Python statements, including my if statements, my else statements, and my for loops as well. Pass, oh, see, that's what I was thinking. I was thinking of pass. Pass does nothing at all. Right? So if I'm printing, not romped, print x if x. Execute. I think these fancy computers can run fast, but not when the internet's slow. Alright, so it's not really compiling right now, so I'm just gonna go over to these examples on the right and left. So here would be an example of continue. So while x is less than 10, I'm gonna print, oh, there we go. Now it decided to work. So we have is, we're going to print x is currently value of x, and then specify x is still less than 10, so we're adding a value. And then after we add this incrementation, we say if x is equal to 3, we're going to print. Otherwise, if x is not equal to 3, we're just going to continue. So, oftentimes it's not necessary to add these specific statements as long as you understand the flow of the specific loop that you're using. In this case, as we can see, if x is equal to 3, break out of the loop. And as soon as x reaches 3, x is currently 2, adds 1, and it breaks out of the loop. Here is a classic example of a for loop. So while true, and true is always going to be true no matter what. So this will just print this statement forever until you pull the plug. All right, now we're going to cover a range, which is a pretty useful function when dealing with loops. What range does is it creates a list of numbers from an initial point to a final point. So, for example, print range from 0 to 10. And this is specifically not including 10. So if I wanted to include 10, I would have to say 11. And yes. So Python 3 is a bit different than Python 2. Python 2, for example, will actually save specific location in memory for ranges to create lists. Python 2. But Python 3 has a feature where, if you're using ranges often in loops and you're iterating through hundreds of times, you don't want to be wasting memory creating a loop just for that, creating a list just for that specific iteration. So what it does is it creates an iterator that doesn't actually take up memory, and it kind of goes through the incrementations as if it were a numbered list, but it's not taking up any space within memory. So a way we could use this, I'll make a for loop, for example. So I could say for x, or for a number, in range from 0 to 11, print that number. And this should print 0 through 10, right? So this is kind of like a quick way to just iterate an X amount of times. Over here, like you can have a specific starting point, specific stopping point. Just use those variables that you created. So we also have the feature of step size, just like we did with our indexing, our string indexing and list indexing. So we can pass a third argument into this range, which is step size. So if I specify step size of 2, what you're going to see is we're going to start 0, skip 1, 2, skip 3, 4. Same goes for something like this. Actually, I don't think that works for ranges. Right, so over here is a kind of like notification letting you know the differences between ranges in Python 2 and Python 3. So in Python 2, there's two different kinds of ranges. You have range and you have range X. Range actually makes the loop, and X range just makes an iterator that kind of increments by value. Python 3 by default uses X range, so it's not actually storing a list of numbers in your memory. Right, so see, the functionality is the same, except this is taking up memory and this is not. And in Python 3, there's only one, and it's range, and it does the same as this. So they kind of ditched the previous method altogether. All right, I'm going to go over, this is the last thing, so we're going to wrap up after this. List comprehensions, they took me a while to understand. It's a bit complicated, but basically what they are is they allow you to make lists, but in a lot simpler way. So in a way, it's a for loop within a single line of code. And there's an example of it here. The syntax is a bit odd, right? So I'm going to just say list, or you can't use list. So list is a predefined term in Python. So you don't want to be overriding predefined terms. So I'll just say lst is equal to, and what this says is x, or in other words, letter. Right, so I could write letter. It's just a bit lengthy. So letter for letter in Word. And I'm going to make this a little bit simpler. I'm just going to say x. So what this is basically saying is element, and you can actually change this and do different stuff with it, but basically what this second part is saying is, this is a regular for loop right here. For x in Word, right? And this lets you modify each one of those elements or not. So if I just leave it as it is, it'll just treat it in a simple way. But this lets you modify, and we'll show you an example of that later, in different ways. So if I just do this and then I print my list, what we're going to see is we have a list of 4 separate elements. And it iterates through this string. And for each x or letter in this string, it'll assign it to a new index of this list. So for example, if we have a range, right? We have a range of 0 to 10, and 11 is not including 11. Make sure to put the bracket at the end. I can change each index. For example, I can say x squared for every x value in this range. So when it creates this list, it's going to first say, okay, for every integer in this range, and the actual value that it stores in the list you created is the first argument you pass it, which in this case would be x squared. And I need to print this. As we can see, we took a range from 1 to 10, and we created a list of the squares of that list, of that range, sorry. There's other things you can do. So for example, at the end of your for statement, right, you can add conditionals. So you can say, only if x modulus 2 equals 0, so only if it's an even number do you add it to this list, right? So if x mod 2 is equal to 0. Now this should give me the square values for every even number in the range from 0 to 11. And there we go. We have 2 squared, 4 squared, 6 squared, 8 squared, and 10 squared. So if we were to actually try to do this in our previous method with the list, it would take a lot more than one line of code. So even though this does look a bit confusing and it took me a while to kind of get the hang of working with this, it's definitely a more efficient way to create iterated lists. So here's a pretty cool example right here. So what this is a converter that takes a list of Celsius values. Right, so if I had Celsius, and I'm going to create a list of different temperature values. Now I'm going to make my list comprehension, and I'm going to title it Fahrenheit is equal to, and in here I'm going to use some spaces just to keep things from being cluttered. What I'm going to do is I'm going to say, in this example specifically, what it does is it casts the integer 9 as a float, but Python 3 does that automatically with the division operator, so we actually don't have to specify that. And also you could just write 9 dot or 9.0 to specify that it's a float. So we could do that divided by 5 times temp, which is going to be our variable in this case. So it's going to be our x, or a variable. We just call it temp because we know that it's a temperature. So we try to be more specific with it. Plus 32. And what this is this is actually the equation for converting Celsius to Fahrenheit, right? And then once we specify, basically what this bunch that I wrote over here is, this is basically saying, this is the x squared in our previous list comprehension, right? So where we specified our first element as x squared, that's what we're doing over here. We're taking temperature, or in this case x, and we're kind of modifying it quite a bit. We're multiplying it by 9/5, and we're adding 32 to it, right? And then just make sure my parentheses are correct. I don't think they are. I have an extra one. This is for this. No. Yeah, I do have an extra one. So I need one over here. There we go. So then once I specify the modifications that I want to make to my specific variable, what I do is I say for temp in Celsius. So what this does is basically, it says for every item, in this case being temperature, in our list of Celsius. We're going to modify it in this way, and we're going to create a new list Fahrenheit with those values. So now if I print Fahrenheit, there we go, we have our conversions. So 0 degrees Celsius is 32 degrees Fahrenheit, and so on and so forth. So, you can see how this would be useful, because this might take a bit more than a single line of code. I know it carried over to the second line, but if I were to just drag it out, this is a lot of stuff that's going on just in simple line of code. You're creating a whole new list with modified values from a previous list, and you can even pass specific conditions. So if only if temp is greater than a certain value will I actually put it into my new list, and so on and so forth. Right, so that pretty much covers all of it. I mean, this last part just says that you can have nested list comprehensions, which, oh boy, I've seen some very complicated nested list comprehensions. You just look at it for 30 minutes, still don't really know what's going on. So they can be complicated, but I'd recommend starting off simple, just kind of getting the hang of what it is that you're doing for each single one of these, chunks of code. But yeah, do you have any questions? Everyone's got it. That's good. Right, so again, if you ever need to take a look at any of these files, they will be available here. I will be updating the next week's material. Next week we're actually not going to have a meeting. The campus is closed on Friday, so in 2 weeks we will see everyone again. But I'll post the part 3 relatively soon, just so you guys can kind of get a head start on that material. But we're going to get into functions. And once we actually get into functions, I can start giving you guys assignments to work on, and it's going to be a little bit more interactive. I just mainly wanted to get all of these, syntax and basic data types and so forth covered with, so you guys are a bit familiar with, what we're working with. But yeah, I think that's about it for me.